Brain Rules, 12 Principles for Surviving and Thriving at Work, Home, and School by John Medina. In-depth summary. John Medina's Brain Rules explores 12 fundamental principles that explain how our brains function and how we can harness this knowledge to enhance our lives. Rooted in neuroscience, biology, and psychology, the book provides practical advice on improving productivity, learning, and well-being. The insights challenge many common misconceptions about the brain and offer strategies for optimizing brain performance. Rule 1. Exercise boosts brain power. Medina emphasizes that physical activity is not just important for maintaining a healthy body, but is essential for a well-functioning brain. Historically, humans evolved in an environment where movement was a necessity for survival. Our ancestors spent most of their time walking and foraging, which contributed to the evolution of our brain. Research shows that exercise stimulates the production of brain-derived neurotrophic factor, BDNF, a protein that supports the growth of new neurons and protects existing ones. It enhances memory, learning, and mental agility. Moreover, physical activity improves blood flow, delivering more oxygen to the brain, which enhances cognitive function. Aerobic exercise, in particular, has been shown to reduce the risk of dementia and cognitive decline. Practical implications. Integrating regular aerobic exercise into your daily routine can significantly boost brain performance. Even a short, brisk walk can increase alertness, focus, and creativity. Rule 2. The human brain evolved. Our brain is the product of millions of years of evolution, and its structure is a reflection of the challenges our ancestors faced. Medina explains that the brain has 3 layers: reptilian brain, basic survival functions like heartbeat and breathing; mammalian brain, emotions, memory; neocortex, complex thinking, problem solving. The evolution of the brain was influenced by the need for humans to solve complex problems in ever-changing environments. This adaptation explains our capacity for abstract thinking, creativity, and social interactions. Practical implications. Understanding that the brain evolved to solve problems in a constantly shifting world suggests that challenging the brain with new problems, learning new skills, and adapting to changing circumstances can keep it sharp and functional. Flexibility and problem solving are core to brain development. Rule 3. Every brain is wired differently. Medina discusses how no two brains are the same. Every individual's brain is wired uniquely, shaped by their genetics, experiences, and environment. Even though the basic structure of the brain is similar in all humans, how the neurons connect and communicate varies greatly. This uniqueness means that everyone learns differently, and what works for one person might not work for another. This principle is key in understanding why standardized teaching methods or one-size-fits-all approaches to learning often fail. Personalized and adaptive learning strategies are more effective because they align with the brain's inherent diversity in wiring. Practical implications. In education and the workplace, personalized approaches should be encouraged. For example, some people may prefer visual learning, while others might excel with hands-on experiences. By recognizing and embracing individual differences in how people process information, we can enhance learning outcomes and productivity. Rule 4. People don't pay attention to boring things. Attention is a critical component of brain function, but the brain has limited capacity for sustained focus. The average person can only maintain attention for about 10 minutes before their mind starts to wander. Moreover, the brain filters out stimuli it considers unimportant or monotonous. Emotion, novelty, and meaning are the key drivers of attention. The brain is hardwired to prioritize emotionally charged events or experiences that are novel or surprising. This explains why storytelling, humor, and interactive engagement are so effective in holding attention. Practical implications. To capture and maintain attention, especially in educational or professional settings, information should be presented in an engaging and emotionally resonant way. Breaking up lectures or presentations into chunks with varied content, stories, or humor can reset the brain's attention clock and make learning more effective. Rule 5. Repeat to remember. Memory forms in stages, and repetition is crucial for moving information from short-term to long-term memory. The brain encodes new information, but without reinforcement, much of it is lost. The key to memory retention is spaced repetition, reviewing information multiple times over increasing intervals. Emotion also plays a significant role in memory retention. When something is emotionally significant, the brain encodes it more deeply. This is why we remember emotionally charged events more vividly than neutral experiences. Practical implications. To improve memory retention, repeatedly revisit new information. This spaced repetition, combined with emotional engagement, strengthens neural connections, making it easier to recall information when needed. In practical terms, studying or practicing skills over several sessions is far more effective than cramming. Rule 6. Remember to repeat, building. On the previous rule, Medina explains that memories are not static. They degrade over time unless revisited and reinforced. The process of reviewing memories allows the brain to consolidate them, transferring them from short-term to long-term storage. Sleep plays a critical role in this consolidation process. During sleep, the brain organizes and strengthens the neural connections related to newly learned information. Practical implications. To retain information effectively, schedule periodic reviews of learned material. Also, prioritize sleep, as it is during sleep that the brain consolidates memories, ensuring that learning is solidified and not forgotten. Rule 7. Sleep well. Think well. Sleep is essential for brain function. Without adequate sleep, cognitive abilities such as attention, memory, and decision-making deteriorate. Sleep deprivation affects the prefrontal cortex, which is responsible for executive functions like judgment and reasoning. Chronic sleep deprivation can lead to memory loss and impair the brain's ability to learn. There are different stages of sleep, and each stage plays a unique role in brain function. REM sleep, for instance, is crucial for emotional processing and memory consolidation. Deep sleep helps with tissue repair and waste removal from the brain. Practical implications. Ensure that you get enough sleep, especially if you need to learn new information or solve complex problems. A well-rested brain is more capable of creativity, problem-solving, and retaining information. Rule 8. Stressed brains don't learn the same way. Stress, particularly chronic stress, wreaks havoc on brain function. It triggers the release of cortisol, a hormone that, in excessive amounts, impairs memory, decision-making, and emotional regulation. Long-term stress can even damage the hippocampus, a brain region critical for memory formation. While short-term stress can sharpen focus and improve performance, chronic stress does the opposite. The brain, in a state of prolonged stress, shifts into survival mode, prioritizing immediate survival over long-term learning or planning. Practical implications. Managing stress is essential for maintaining cognitive function. Techniques such as mindfulness, regular exercise, and strong social connections can reduce stress and improve brain health. For learning and productivity, creating a low-stress environment is crucial. Rule 9. Stimulate more of the senses. The brain processes information from multiple senses simultaneously, and combining sensory inputs enhances learning and memory. For example, when we experience something through both sight and sound, our brain creates a more robust memory trace, making it easier to recall the information later. Medina suggests that learning and communication should incorporate as many senses as possible. The more senses engaged, the stronger the learning experience. Practical implications. In presentations, teaching, or communication, use multimedia tools that involve sight, sound, and even touch. Engaging multiple senses makes the material more memorable and easier to understand. Rule 10. Vision trumps all other senses. Of all the senses, vision is the most dominant and powerful. The brain processes visual information much more efficiently than auditory or textual information. Our ability to understand and remember visual input far surpasses our capacity for text or sound alone. Visuals are processed faster, and we retain them more vividly. This is due to the brain's evolutionary reliance on sight for survival. As a result, visual aids are far more effective than textual information when it comes to conveying complex ideas or reinforcing memory. Practical implications. In communication, education, or presentations, prioritize the use of visuals, images, diagrams, and charts over text-heavy slides or lengthy explanations. Visual storytelling is more impactful and leads to better retention. Rule 11. Male and female brains are different. Although the basic structure of the male and female brain is the same, there are differences in how they process information, manage emotions, and respond to stress. These differences are driven by both biological and hormonal factors. For instance, women tend to outperform men in verbal memory tasks, while men are generally better at spatial reasoning tasks. Women are also more likely to use both hemispheres of the brain simultaneously during problem solving, while men tend to rely more heavily on one hemisphere. Practical implications. Understanding these differences can enhance communication and collaboration between men and women, whether in the workplace, education, or personal relationships. It also highlights the importance of diverse approaches to learning and problem solving. Rule 12. We are powerful and natural explorers. Human beings are inherently curious and driven to explore. From birth, we are natural learners, constantly seeking out new information and experiences. This innate curiosity fuels brain growth and development. Exploration and experimentation help the brain form new neural connections, improving adaptability and learning capacity. Adults often lose this sense of exploration, but Medina argues that maintaining curiosity is critical for lifelong learning and brain health. Practical implications.